Okay, so I decided to do a challenge where I had to figure out how to make a part go to the speed of light. Now, what a lot of people did, was just making it going on one axis, right? Just going on one axis. That would be like going over there at the speed of light, like you're going in one direction. Okay, that's not what I did because that would be too hard and you wouldn't be able to see the part. Instead, I'm using rotation. Let's say we have a part right here. Right now, we're not detecting how far it traveled, we're just detecting how much distance it traveled while spinning. So, yeah, the part's gonna be right at the end of the part, and this is gonna spin. And I have everything calculated. It can go past the speed of light over 400 times, like 400 times the speed of light. It's insane. If this was even longer, we can make it go even faster. It's crazy how overpowered rotation is. Now, this is the code that I have. So we wait 5 seconds, os.clock, rotation changed, degrees. So we're going to start the loop. We add a rotation change because rotation change is basically every time it changes the rotation, right? That's how many times it changed the rotation. And this is just adding to the z for rotation, and we're printing the data, which is a table, and then rotation changed. If this gets to 1, like if a second passes and then, this resets, these two variables reset. So let's get data. Well, that's how we figure out the speed of light per second, right? Or like how fast is it compared to the speed of light? Like, is it 1.1 times the speed of light or whatever? So this is how I figure out everything. We have the circumference, which is when it spins, how big the circle is. The circumference, we should know what that is. Rotations per move, like how many full rotations, like going from 1 point, like 0, all the way to 360, right? Like a full rotation, okay? That's how many rotations it is per move. How many studs it moves per move, like like for the degrees, how many studs it moves every time. And then we have studs per second, which is how many studs it's moving per second. Then we have meters per second, how many meters it's moving per second. And then we have speed of light per second. And you should already know what that means. So I have the degrees at 1,000,000. Okay? The higher the degrees, the faster it goes. So we're gonna run. It's gonna wait 5 seconds, and we're just gonna see what happens. So as you can see, it's spinning pretty fast. It doesn't look like it's the speed of light, it just looks like it's spinning a bit. But that's just because, helicopters, it seems like the blades are just still in the air. That's the same effect. So, the 60 and the 61 on the sides, that's basically, how many times it was spinning in that 1 second. Not spinning, like, not how many rotations. I mean, like, how many times the line 24 ran until 1 second came along. So here is the speed, how fast it was going. It's almost at the speed of light. So that's like 1 point blah 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 times the speed of light. That's how fast it was going. So this is already as fast as the speed of light. And if we look at the 61, it's faster because, it ran line 24 another time. So it's even faster. Now, if we tried to make this to 100 million, yeah, that's 100 million. If we made degrees 100 million, then it will be going extremely fast. As you can see, it even looks faster. So now we're just going to get the one that says 62, right? Well, now it's like at 60 and 61. At the beginning, it's going to be a little wanky, right? So we're just going to look at 61. And we're just going to see. So the speed of light, it's going 101 times about 102, actually. 102 times the speed of light. That's fast. Now, I've gotten this to go even faster. Like, it completely stops at 500 million. It stops mid-air and it just doesn't go anymore. As you can see, it stopped. And it's still going, but I think it's just going too fast where you can't see it. So I'm not going to do that. We're going to go 400 million, and that should have interesting results, because that's even more than 102 times the speed of light. So we're going to look at this, and as we can see, that's 407 times the speed of light. That's crazy fast. It might not look like it, but it is. Now, the only problem is it's true and not true at the same time. Because one, the challenge is one destination all the way to the end. Like one axis. This is still technically one axis, but it's rotation, not movement. So, you know, that's rolled out. And another thing is, it's not really moving like this. So we have this, right? Let me get the rotation right here. So we can rotate it. It's moving like that in parts. It's not moving separate. Like, it's not moving, let's make this like 0. Right? Let's say we made rotate 0. So we go in here, it's not moving like this. It's not moving like this, right? It's not doing that. What it's doing is it's doing like something like this. We have this like that. It's moving in parts. So I don't know if you can call this the speed of light or whatever. But, you know, that's just my take on it. This was fun. I bet there's flaws in this. I have a game that you can check out. It's uncopy locked, so go try it out yourself. I have everything in here, and this basically just, you know, it tells you all the information that you need. And yeah, that's basically all I have. Very fun to make. I didn't really want to make it go from X axis all the way over here. That would have been like crazy, because you wouldn't be able to see it. Yeah, you could use magnitude in a part to see it, or like maybe a camera, but I don't know, it wouldn't look good. I just like this a lot more. So yeah, I could have made it so it was spinning on like the edge of it, like the bottom part, instead of the middle. But I decided not to do that because, you know, I didn't need to. It was going fast enough, as you saw, like 400 times the speed of light. Anyways, I'm just gonna end this video.